Hi, in today's video we're going to take a look at installing dwl on NixOS. We'll be using a custom config.h file, applying a patch, setting up the bar, creating a script to add the time and volume to the bar. Also we're going to use systemd to create a script that will actually set the background wallpaper. We'll also have a script for changing the backlight and the audio output device, as well as several other things. So even if you're not on NixOS, I've got a couple of DWL tips for you. So what we're going to do is actually have a look at the setup of how you can get DWL working on NixOS and some of the gotchas that you're going to need to know to get this set up. So first of all, what we have here is our configuration.nix. And what you'll see is we have this block of code, this let in block here right at the top. And what we're doing is we're actually defining a variable here called my custom DWL package, which is actually going to override the NixOS DWL package and allow us to specify using our own config.h file. So what this will allow us to do is have a config.h file that we have set various things in, like, well, let's have a look. So here's the config.h file. So typically in this is where you will set things like your keyboard layout, for example. So what we have here is the keyboard layout with the XKB options to apply XKB rules for our keyboard setup to do things like swap particular keys around depending on the keyboard we're using. We can also define things like the terminal that actually gets launched. So I've got Alacrity set here. We can also set things like Toffee, which is a Wayland version of dmenu, to actually launch applications. And what we also have here is settings for using the media keys to change the audio volume, as well as a keyboard shortcut to actually warp the cursor, so I can warp the cursor between different monitors. And this is the section where you typically have your keyboard layout, your keyboard shortcuts rather, to launch particular commands or things that you've defined. So let's switch back to the configuration.nix and I'll have some tea. So what we've got there is a single config.h file that's got our customizations in it that we can apply to this override for the DWL package. Now, typically with DWL, another thing that you actually do is have patches to patch DWL to apply different functionality, lighters these days. So what you can see here is I've actually got one patch applied, which is the move stack patch. And what I have, if I just come back out here, so this is the directory with my configuration.nix, hardware configuration.nix, and flake nix and flake lock. And what you'll see is a DWL directory. And in here we have the config.h and the move stack patch. So what we're actually doing here is saying apply this patch as an extra override to the DWL package. Now you can apply one patch and it will work, but if you've used DWL, you know that if you try applying multiple patches to a file, you'll get issues because the line numbers will be out of sync, and so it won't work. So although in the example, in the documentation, it does actually show using this with multiple patches, in practice I found that it didn't work. So what you will actually have to do is, if you have a couple of patches that patch the same file, what you will actually need to do is take a copy of that file. So, for example, I think it was at dwlb.c. So what you would need to do is copy the dwlb.c to say dwl patched or something .c. Make your changes to the dwl patched version, and then create a diff of that file in the original dwl.c file to create a patch. What you'd need to do also is actually edit the patch. So what you can see here, for example, typically what happens is with the patches, you can see these two sections here. These are the two files that's actually patching, A and B, config.h, a.wl.c, and bwl.c. So what happens is you need to actually change, when you do create the diff, it'll probably say something like dwl.c, dwl-patch.c. And what you actually have to do is change the code so that it's basically the patch is actually showing A and B with the same file, because otherwise it won't work. But you can look into that in the DWL documentation. So that's a note about patches. Then what we've got down here is this is the sort of build input. So this kind of builds everything that we specified above. Now what we've got down here is a section where we create a wrapper bar that launches DWL with dwlb as a status bar. So this is the status bar up here. Of course, you could use something like waybar or whatever, but I like dwlb. So the issue is the way dwlb works is, if you can see from this code down here, this is the actual script. What it's basically doing is it's launching dwl with the -s option, and then runs dwlb, the bar, and sets the font. Now, the issue is we actually have to do it this way because in two stages, basically. So we can't just launch DWL with this option. We actually have to basically have a wrapper script. And the other thing that this will actually do, I should have mentioned, is this setup will also create a desktop entry that works with a login manager. So I also have GNOME set up on this machine. So when I exit out of DWL, it takes me to the GNOME login screen with DWL and GNOME as both options I can log into. So you don't actually have to set up a script or anything to create the desktop session for the login manager. It's done automatically. Right, so that's the bit we have in our config.def. So you can see I was mentioning the setup of the Nix file, and there's the flake.nix. Okay, we don't need to have a look at that. Okay, so that's the configuration.nix. Oh, bugger, hang on. Let me get back to that directory. So as I said, we've got the configuration.nix, the flake, and the DWL directory here with the config.h and the move stack patch. So the next thing is, as I said, the status bar. So what we have actually, yeah. Okay, so this is actually the status bar is a script that will set this up here. This basically this thing here, which is the time and the volume. So what we have here is, in the previous setup, we configured the DWL bar, yeah? And this script, which we're actually going to use systemd to launch, then pipes in the volume and the time. So what we've got here, first of all, is we're actually exporting the path. So what we're doing is you can see here what I'm doing is actually setting it so that it looks in my home Nix profile bin directory for things installed with Home Manager, as well as the path to the system binaries. Now, this bit of code is important here because, as I said, what this status bar is going to do is use systemd to start this up. But if we're logging into GNOME as well on the same machine or another desktop environment, we don't actually want the status bar to run because it's not going to be shown. So what this bit of code does is it uses the xdg current desktop and checks if it's GNOME, and if it is running GNOME, the script exits, basically. So dwl works with wl roots, whereas GNOME works with mutter, and they don't work together, basically. WL root stuff doesn't run on GNOME. So what we've got in this bit here is the actual settings. So what we're doing is we're actually creating a timer for both the volume and the time that runs every second, because obviously if it's a clock, it's got to run every second to keep the time. So what this basically does is it creates a loop every 60 seconds. And what you'll see is we've got a volume icon. And what it does is it uses WCTL, which is a pipewire command line utility to check the volume and stuff. Okay. So what we've also got down here is a volume icon. When I change the volume, these little lines don't increase or decrease. It's just a static volume icon. But if I mute the audio, it changes to this icon, basically. Okay, so that's that. And then what we have is basically we store that script in our home bin directory. And so what we've got next here is a status bar service. So what we do is we create a status bar service file in our home folder .config systemd user with the following code. So what this basically does is we've got the description here. So this is the neat bit, is that this only runs after the graphical target is started. So once you log in, this is going to show up straight away, basically. Now, the reason I chose systemd was because it's kind of these are long-running service things, and it's a better way to do things than trying to put commands in a shell file like your zshrc or something like that. Another note is that Linux does have auto start files, but they're only for GNOME. So in your home.config directory, if you're running GNOME, you'll see an auto start file directory, and you can create files in that will automatically start different applications. But that wasn't going to work for this setup, so that's why we're using systemd. So what you can see is after binds to exec start, that's the path to the script up above I just showed you, and it's wanted by the graphical session target. So what we do is we put the script into place and the systemd file, and then what we can do is run systemd --user daemon reload, enable status bar service. That creates the symlink, and then start the service. So what that will do is every time you log in, it's automatically going to create this little section in your dwl bar. So that's the bar. So let's have a look at the where is it? Wallpaper service. Okay. So the wallpaper. So this is how we set the wallpaper. As you can see, we've got a steal from Akira that I used. Was it Real Gun? Oh, I forget the name of it. It's going to annoy me now. Real ESG GAN NCNN Vulkan. So that's a command line tool that can be used to upscale images. So that's my wallpaper, and basically this is how I set it. what we have here, again, is two parts. We've got the wallpaper.service file. So what we've got here is description, wbg wl root wallpaper. So wbg is the name of the package that we're using. So I have that installed with Home Manager, and we have exec start bin wallpaper. So if we have a look at that, bin wallpaper, what we do here is actually set the path. So we set the path so that it can actually find the scripts, make sure we're not on GNOME again. And basically what we do is then we have a path to the wallpaper, and to run the wbg script, the only thing it accepts is the path to a wallpaper file, and then it will display it on all the monitors. So that's a really simple, lightweight WL root wallpaper setter. And that's how we can create a little script to basically start it up, and then use systemd to actually start the service. And it's basically the same deal. You do a systemd daemon reload, enable the service, and once you log in again, it will actually have the wallpaper set. So another thing that kind of crops up is when you're switching from a desktop like GNOME to a tiling window manager like DWL, there's some functionality that is built into the settings of things like GNOME that aren't enabled in DWL. So two of those are the brightness for the keyboard backlight, and also setting the audio input and output device. So typically on things like GNOME, you'll have like a little drop down menu here where you can change the audio input device, the backlight, or you could do it in the settings app, but we don't have that. So what we need to do is come up with something that we can use as a replacement. Just finish off the tea. So what we've got is bin backlight. So this is basically to change the keyboard backlight. Now, when I have keyboard shortcuts set up with the media keys, so that when you press the up or down volume keys, the volume level here will actually change. Typically with things like volume level indicators and brightness level indicators, you'll get a little heads up display on most desktop environments, whether it's Mac, Windows, GNOME or whatever, KDE, showing you little dots showing you the level of the brightness or the increment of the volume changes. So you'd see, from 0 to 100, and you can actually visually see when you're pushing the keys how far it's gone. There are sort of some overlay tools that can be used to create a little progress bar like that. But for the backlight, basically what I did was create a script that has three settings: on, off, and half, and does what it says in the tin. It either turns it on, off, or half percentage, 50% brightness for the keyboard backlight. So what we have here is a little bit of script usage, the get ops. Now this is another thing I should mention. Right, input usage. Right, okay. So that's what I wanted to mention. I've got two systems set up with NixOS, a Dell XPS 15 2019 and a MacBook Air 2011. And they both have different locations for the brightness control. So what you'll see here is Dell brightness and Mac brightness. So on Intel systems like the Mac, typically the path to the brightness command, which basically what you do is not a command, it's a file that actually can contain from 0 to, I think it's 225. with 0 being off and 255, and 255 being full on. And if you actually echo a value into that file, it will change the keyboard backlight. But as I said, the Dell has a different file name location. You can see here for the Mac, we have sys class LEDs SMC, whereas on the Dell, it's Dell. Yeah. So that's a slight difference. So that's why there's two different settings for the brightness here. And what we have here is a function that basically checks if we're running, if the Dell file exists, and if it does, what it does is, you can see here, -f, if the file exists, then what we have is DOAS sh-c, and we need to use DOAS for this script because you need elevated permissions to echo variables into that file. So what I have in my setup is I've just got DOAS set to allow any command I want, basically, to run, so I don't have an issue with this. But if you don't, you'd have to define a rule that applies to this backlight script and set it to no pass, so that you're not prompted for a password, because otherwise when you try and use the keyboard shortcut, or the script rather, it will throw an error. So we check if we're on the Dell or the Mac, and basically what we do is we echo the brightness level in. And what we do is, in the script here, it's got a -i option, and that's basically where you pass the level of the level in. So that's basically going to be set to on, off, or half. So what you can see here is this bit of code down here. It says if n input. So where's the input come from? The input is this get option here. So when we run the script backlight -i, whatever is after I is the argument's opt-arg. So you can see this opt-arg thing here. So that's the options argument, which is going to be a variable called input. So what we can do is we can check what was passed to the input option, the -i option, whether it was on, off, half, and if it's none of those, we echo an error, basically. So it checks if the variable is set, and if it is, it then basically runs this. So we basically just have to run backlight -i on, off, or half to set the backlight level. So that's the backlight level. What I also want to do is mention the audio. So why are you? I don't want to edit a macro. What's it doing? Right, okay. So what we're doing is we're using Pipewire on this system, and typically when you run Pipewire, the audio devices can have sort of quite long names like Intel-PCA, whatever. But there's actually a way to simplify them. .config wireplumber. So what we have here is, in our home directory in .config, I've created a directory called wireplumber, and inside that another directory called wireplumber.conf.d. And what this has is a conf file called device-rename.conf. Now, a couple of years ago, the syntax was different. It had a different syntax. It may have been something like Lua or something for the wireplumber config files, but now it's changed to .config. And what we can do is we can actually, let me see if I can find the, wireplumber rename devices. Okay, so as I said, we create the directory here. If we run this command here, pw-cli list-objects node, what you'll see is it'll spit out a load of stuff here. You can see here. Where is it? Yeah. Right, so what we've got here is the things that we're looking for are sinks and sources. Sinks are the output, sources of the input. So what we can see here is audio sync. So that is the laptop. So what you can see is I've actually changed the names here. So the audio sync is the laptop. Capture here. So what you can see, capture, that's the built-in mic. And what we also have is listings for Yeti Blue Snowball down here as well. If I can find it. Yeah, Blue Snowball. So what you'll see here, what I'm talking about is, by default, the node name is alter input.usb blue microphone, that. Not very easy to reference in a script, okay? So what we can actually do is we can rename these devices to be more user-friendly. So the other issue is that the microphone, the built-in microphone and speakers actually have the same name here. So let me just switch across. So I said what we do is we create the configuration file that I just showed you. And what you'll see in this, I'll go through this in here. What you'll see is the object path. So if I scroll back up here, try and find the one with the, object path. So you can see here, so we've got playback here. So that's the built-in audio playback. So that's the built-in speakers. See if I can find the other one. And capture. Okay, so you can see here they've both got the same node name, but they have a different object path. So the capture is the built-in mic and the playback is the speakers. So what we've actually got here is this setting for matching object paths and actually updating the node description. So what you'll see here is object path, and we've got playback. So that's laptop. So we're renaming this output to be more friendly as laptop. And then mic, so that's the internal mic. And then what we've got here is speakers. So these are my old, must be about 25-year-old sound sticks, Harman Kardon sound sticks. So we can reference those as speakers. And then what we have down here is the object path for the Snowball capture. So that's the Yeti Blue Snowball mic that I'm using. So that's basically how you can set up the device renaming. And then what you do is after you've created that config file, you run systemctl-user restart wireplumber service. And then what I have, let me see if we can close that, in audio switcher. Okay, so what I have here is a script that I use on the command line to switch audio devices. Now, typically when you plug in a new audio device, it may be automatically recognized and it will switch to it. So if you plug in your speakers, they'll automatically be set as the default device. Same thing with microphones. But if you want to change back and forth, this is where this can come in handy. So what we have here is input and output. So input is for the mics, output is for the laptop speakers or the external speakers. And what we have down here is that we have this wp-ctl status command. So wp-ctl status, and this is the wireplumber command line application. And what you'll see here is clients, audio, and what you see is syncs, laptop. Now, the other thing I should mention is that actually when you plug in headphones in or out, there doesn't seem to be, at least on this particular setup, something that actually detects those as headphones. So we use laptop to basically set to the external speaker, the laptop speakers, or if the headphones are plugged in, it will just switch it to the headphones. So you can see here we've got the syncs set to laptop, the source is Yeti and mic down here, so you can actually see which are defined as the default. So when you plug in a new device, what you can do is run wpctl status, and you'll actually see what is set as the default input and output audio device listed here. You can't change these pre-configured device names down here, I don't think. But you can see here things like video are also listed. So what this does is basically it checks the device names, and this is set up. You can see this case statement down here. So what I have is two case statements, one for the input and one for the output. So it checks if you pass in audio switcher -i, mic, or Yeti, and then it runs the function to switch to that device. Or if you're using the output option with the -o option, it will either switch to laptop or speakers. So I wanted to take that a bit. Oh, God's sake, what is it doing? So what I did next, okay, let's have a look. Okay, so what we have here in our zshrc file is some completions. Now you can use completions with an fpath directory, but what I found is if you do that, it actually really slows down starting zsh up. So we put the completions in this file here. So what you'll see is when I run audio switcher -i, press tab, it actually lists the input devices it can complete to. Or if I do -o, press tab, it lists the output devices. So again, these file names, these names here are related to the wireplumber settings that I applied in that config file. Okay, so that's how this works. Basically, it's got the arguments and it auto-completes -i and -o and -h for help. And what we've also got is the same deal for the backlight. So what this does is basically checks if the volume for on, off, or half. So if I run backlight -i and press tab, it will prompt me here with the auto completion, so I can press half and it'll do half or on or off. So that's just something to make life easier instead of having to manually backlight -i. Maybe that's not a good example. Let me do the audio switcher -o. You can auto-complete to speakers there if I want, by pressing tab. So there's just some options for setting the backlight level using auto-completion. So that's pretty much most of the stuff I wanted to cover in getting everything set up. So the reason why I prefer DWL is because little things like actually launching applications. You can use the Tofi application launcher. So if I press the keyboard shortcut, you can see I get the application launcher show up here to launch graphical applications that have got a desktop entry. Now, if you ever use GNOME, what you'll know is every time you press the keyboard shortcut for the GNOME built-in application launcher, what happens is it zooms out and kind of gives you this kind of overview. And it also zooms out the second screen as well. So it's really egregious. It really gets in your face actually launching applications with the GNOME application launcher. Is really sort of irritating. The other issue is actually focus stealing. So for example, when you launch things like MPV, to open a video on GNOME, what happens is MPV gains focus. So if you use something like Emacs diode to open a video file on GNOME, what happens is it opens the video on your second display, but then MPV gains focus and you have to switch back to Emacs. And that's really irritating. You have to like use the heads up display or click to regain focus. And that's really irritating because the amount of times you'll actually be launching something, you know, and you think you've got focus on one program and it starts typing in another. Really irritating. So nice and easy. I've got it in, actually got it in, there we go. So that's tiled mode, and the move stack patch basically actually allows you to move things up and down. It's the only patch I ever use. So you can see I can move those up and down with the keyboard shortcut. So I think that's pretty much it. Took a little bit of getting fixing things up to get all this working, come up with different solutions. Instead, the wallpaper set using systemd as well as the clock up here. The other thing I should mention is another thing you typically have on most desktop is up here you have the battery status. I could have made a battery status thing up here as well, but it turns out that Emacs Doom modeline actually has a battery indicator that you can display in Emacs. So what I'll just do is I'll just quickly come through and show you my Emacs init.el. What I've done is recently I've changed this to use package for everything. So if you want to copy bits of code, it should hopefully be a bit easier. So just on the Emacs side of things, this is how you bootstrap use package here. And what we do is we specify the package archives. These are general settings for set queue. And let me just come down to the Doom modeline section. So what we've got here is the tab bar. So you can see up here, I've got no tab bar, but if I actually click up here, I've actually got a custom icon, is actually the menu up here. And that's what this section of code does. Buffer display list, functions, hooks, key maps, fonts. Okay, Doom modeline. Okay, so this is the Doom modeline battery. So what we have here is use package, Doom modeline, and then all these set queue options. And at the end, display battery mode T. Now, by default, what happens is the battery will actually be displayed to the left of these things. And I wanted it displayed right next to the time. It turns out what you can do, this is Doom modeline now playing. So what this is something that uses player CTL with Empress enabled applications like MPV to actually show the playhead position of a video in the Doom modeline. And by default, it actually disables this functionality for Chromium and Firefox. And actually, Firefox's implementation of Empress is currently broken. What happens is, if you play a video with Firefox and say it's a 10-minute video and you pause 5 minutes in, what happens is the playhead position carries on increasing even when it's paused. So that's why it's disabled for Firefox and Chromium. Now, this is the section I wanted to mention here, this Doom modeline define modeline main. What you'll see here is we've got the now playing thing here for the Doom modeline now playing. But at the end, what we have is battery and then time. So what you'll see here is that corresponds to this section. So it will show things like the VSC is like the get status, the mode, minor modes, all that kind of stuff. But this is how you can set the order of the elements in your Doom modeline to show the battery right next to the time. And since I use Emacs, it was just easier to enable that than trying to faff about with the script to actually add a option that would actually check the battery status. One thing I should mention is that there wasn't a way to, without checking every second, there wasn't a way to automatically get the volume. So it's running every second anyway, this little block of code for the time up here. So it doesn't really matter that, it's doing the same thing for the volume. But there wasn't a way to actually get the volume status change only when it changes. So that's why we have to poll it every second. But that's just another thing I wanted to mention, is actually getting the battery status working as well in the Doom modeline, so that you've got another little thing that's by default missing on tiling window managers that you'd get on a desktop environment. So I think that's pretty much it. I'll put links to all this under the video. And I'm a lot happier using DWL than GNOME because, as I said, it's got some really annoying sort of features, and there's just no customization. You can't sort of change anything. Although it works, you can kind of use it. There are just little things that are really irritating, like, as I said, I can launch the application launcher without it zooming out the screen. The other thing is, if I switch across to this one here, is I can actually launch the application launcher, you can see up here, on another display. So typically on GNOME, what happens is, even if you have got your cursor focused on the other display and you bring up the application launcher, it will still be displayed on the primary display. It won't switch monitors depending on which one's got focus. So it's really irritating. You switch to another display, launch the application launcher, and it's displaying on the other screen. That's just another little thing that really bugs me, that DWL solves, as well as the focus issues with applications gaining focus when you don't want them. So hopefully all these little tips will let you get up to speed with DWL on NixOS, and even if you're not on NixOS, give you a few tips for actually how you can launch applications using systemd, like the wallpaper, or typing in a bar up here. As I said, you can use things like, I forget the name of that other bar, waybar, is it? But then you kind of got to style it with CSS and all this palaver. Whereas I just like this plain simple bar, gets out the way. It's really small, does what it should, shows you all the desktops that have got stuff on them, the application name, and the date and time up here. You'll see I've got the time down here as well in Emacs. I did used to have the time down here in Tmux, but I removed that because I didn't want that. And the way you can do that is Tmux. So if you want the time, so let me just show you. Okay, you can see I've got the time down there now. Since I've got it up here, it's, you don't need it as well. And although there's a little thing, I found just having that kind of a bit distracting. I'll show you what I mean. So you can see here, this is how we set the time. Set -G status -right, hours, minutes. And if we don't want the time here, we just set that to be empty. Okay, so if I reload that, I just think that looks a lot cleaner without that little thing in there. It's a bit less distracting. I mean, it's just a minor thing, but it's one of those things that kind of bothers me. So this is good because I can see the time on all my displays up here. I can see the volume control, because as I said, we don't really have a on-screen display showing the volume control as we're pressing the multimedia keys. So this is a good sort of workaround. We've got workarounds for the backlight and switching audio devices. And as I said, with DWL, if we just come back up here, just remember about the patches. you'd have to look up how to manually sort of patch files that you can use. So that only really applies if you're trying to use patches that patch the same file, like dwlc or something. I don't think there's any other options that you can specify. I think you've only got this config.h option that you can override. So I don't think you can override other files. You actually have to use the patch functionality for that. So you have to read up on that about how you, patch the files. But I gave you a few tips earlier in the video. So that's all for now, and I'll wrap that up here. Stick links to all this under the video and hope that helps out.